Assalamu alaikum, dear students. This lecture is about frequency distribution of scale data or quantitative data. Normally, quantitative data are of two types. Some data are count data and some data are scale data or continuous data. So, how we form a frequency distribution from discrete variable or a continuous variable. So I will show you here how to form a frequency distribution for both cases. So what is frequency? Normally we understand by frequency by number of occurrence of an event or a value or an observation. For example, say I here write some number, say 4 6 7 6 3 6 7. So what is the frequency of 4 or 3? Say our our digits are if we label is as x, then we have 3 4 6 7, this number. So what is the frequency? In this data we can see that 3 is occur only one time, so the frequency of 3 is only 1, and 4 occurs also only one time, so frequency of 4 is also 1. We can see that 6 occur 3 times, so frequency of 6 is 3, and finally 7 occurs 2 times, so we have frequency of 7 is 2. So this is a frequency table, and we can see that x are discrete 3 4 6 7, so this is a discrete frequency distribution. Sometimes we called it ungrouped frequency distribution. So here our example. In first example I will show how to create frequency distribution from discrete data. So here I consider a data which denotes the number of weaving defects observed in the 30 pieces of fabric. So here are the number of defects. Suppose in first fabric we have 4 defects, in second fabric we have no defects, so 0 is the number of defects, and so on. So at first we have to identify the minimum number and the maximum number. So in this data, out of 30 pieces of fabric, number of defects, the minimum number of defects is 0 and the maximum number of defects is 6. So we have the number of defects which is our variable 0 to 6, 0 1 2 3 4 5 6. Now we assign now we count using tally. So how we do it? We have to count it, how much time 0 occurs, how much time 1 occurs, etc, etc. So normally we do this like that. We cut this value or label this value 4, and then we assign a tally sign here, count as 1, then we take it 0 and we again assign 1, then okay, in this way we can do our whole process. So finally what we have, after counting all number, we have the following figures. You can try it at home. We can see that number of 0 is occurred 3 times, so frequency of 0 is 3. 1 occurs 4 times, so frequency of 1 is 4, and 2 occurs 5 times. So when we have 5 times, 2 occurs 5 times, so it will actually like that. We have 4, then we have additional 1. So when we have additional 1, we can give a cross line which indicates 5 defects. Okay, number of count is 5. So after counting 4, and when we count another additional 1, then we give a cross line. This will mean this is 5. Okay, in example 2 we will construct a frequency distribution from group data. So here is the results of hairness index obtained from 20 tests. So we have to construct a grouped frequency distribution by taking suitable or appropriate class interval in exclusive method. So how to construct a group frequency distribution? So to construct a group frequency distribution, we have to find the minimum value and the maximum value. So in this data, minimum is 6.0 and maximum is 7.2. The range is difference between maximum and minimum, which is 7.2 minus 6.0 equal to 1.2, and our number of observation is n equals to 20. So at first we have to take suitable class or appropriate class interval. The formula for suitable class interval, which is very much used and most used formula in everywhere, which is C, also known as Sturge's rule. Here C equals to, the formula is C, that is class interval, equal to R by 1 plus 3.32 into log 10 base 10. So in calculator, using calculator, we have this number 0.23. We can approximate it 0.25 or 0.20, but this distance should be close to original C, which is 0.23. So it will not, I recommend you not to take 0.30 or not to take 0.15 there, so that the difference between the actual class interval and the class interval we take is not so big. Okay, so we have the, in exclusive method we can form the following classes. So since our minimum value is 6, so we start from 6.02. I write here with a comma, not a hyphen. So we write it as first we use close interval 6.0 comma 6.20 open interval. So this means this is exclusive method. We what we say about this. So if we have a point, say we have a data point to 6.20, in which class we assign this value? So in this class 6.20 is excluded, that is it is not in this class, because 6.2 is here open interval, and so 6.2, in the case of 6.2 we will assign it in 6.2 to 6.4, that is in second class. So this is known as exclusive method, where upper limit is not excluded in every interval and lower limit is included. Okay, so if we have a data point like 6.60, so we must assign it in this class, not in this class, because in this class upper limit is not, that is 6.60 is not included. So by taking this, by considering this class interval 0.20, we have the following classes. So there is a portion I want to notice it, that we have the maximum value, which is 7.2. So here we have 7 to 7.20. Since 7.20 is not included here, so we have to take a additional class, which is 7.20 to 7.40. So we just write this class interval here, 6 to 6.20 open and 6.20 to 6.40, etc, etc. Now we count this number. So to count this number, we simply count this as follows. We select this 6.272, which falls in say 6.72 in this class. So we we marks one tally mark, then we level this, and we 6.52, which is fall in 6.52 in this class, so we assign another tally mark. Then we have 6, so we assign this here 6.785, which will fall in this class. 6.08 will fall in this class. 6.64 will fall in this class. 6.88 will fall in this class. 6.91 fall in this class. 6.35 fall in this class. 6.52 6.52 fall in this class, 6.626. So we have this in this class, 7.20 in the last class, 7.12 in the second class, 6.36. So 6.36 will fall in this class, 6.82 fall in this class. Okay, 6.53 fall in this class, 6.78. So we assign this in this class, 6.75 fall in this class, and 6.49 fall in this class, 6.62. So this fall in this class. We have the 5 frequency here, so we add a cross line. So after completing this, we have to count it. So this frequency is 2, this frequency is 3, this frequency is 4, this is 5, then 4, 1, 1. So we have a total n equal to, if we add this, we will have 20. Okay, so this is the formation of frequency distribution from a group data. Here is the answer. We can see that our result is similar to this result, 2 3 4 5 4, 2 3 4 5 4 1 1. Okay, we now see what is histogram. So histogram is nothing, just graphical presentation of a frequency distribution. So here you can say the frequency histogram of hairness index data. So here in a frequency distribution, here we put class interval, that is 6 to 6.20 and 6.20 to 6.40 exclusive. Then we assign frequency, number of observation per interval. Then we draw some bar. So in 6 to 6.20 we can see that there are only 2 observations, so the height of the bar is 6.2, which is this bar indicates. And in 6.2 to 6.240 in this interval, we can see there are 3 observations, so the height of the bar is 3, and so on. So we have the frequency histogram from the constructed frequency distribution. So frequency distribution and shape of the distribution, how we can know that the distribution is not symmetric or some skewness in the data. So what is skewness? Skewness means lack of symmetry. Suppose how deviation from a normal or bell-shaped curve, bell-shaped distribution, this is called skewness. So in this data, this is a simulated data, so I discuss about shape of the distribution and from histogram. So in first histogram we can see that this histogram has a right tailed, elongate to right, and this is approximately same in both sides, which is symmetric. And in this histogram we can see there is a long tail to the left. So if a histogram has a long tail to the right, we called it as positively skewed distribution, and if a histogram has long tail to the left, then we say it as negatively skewed distribution. And if a distribution or histogram is almost similar in both sides, then we say it as symmetric or bell-shaped or normal distribution approximately. In real life, it is very rare to have 100% perfect normal distribution or symmetric or bell-shaped. So what we have just approximately normal or approximately symmetric. So this is the histogram and shape of the distribution. So if we construct a frequency distribution, then we can calculate other measurement like relative frequency, percent frequency, and cumulative frequency. So what is relative frequency? Relative frequency is just for example, say for this class the frequency is 2 and total number of frequencies 20. So the relative frequency is number of frequency in a class divided by total number of observation, that is f by n. So in the first class we have the relative frequency 2 by 20, which will give 0.10. then this relative frequency comes from dividing 3 by 20, so we have 0.15 and so on. So total must be 1. If we convert it to percentage, then we just have to multiply it by 100, then we have 10, 15, 20, that is converted in 100%. So we can say that out of 20 observations, 25% observation hairness index lie in this interval, that is 6.60 to 6.80 exclusive. Finally we see how to calculate cumulative frequency, which is denoted by CF. So in first interval we have f, that is 2, and in second interval we have f, that is frequency 3. So if we add 2 and 3 we have 5. Okay, then if we add 5 with 4, then we have 9. By adding 9 to 5 we have 14. 14 with 4 adding we have 18, and so on. So we understand how we get cumulative frequency. Okay, so what does it mean? Say in this row we have CF equals to 14. This means that out of 20 observation, hairness index of 20, maybe this is fabrics data. Okay, 20 test. So out of 20 fabrics, 14 fabrics hairness index lies between 6 to 6.80 exclusive. Okay, this means this is CF, explanation of CF. So we have this relative frequency, percent frequency, and cumulative frequency from a frequency distribution. So this is called aggregately we can call it as frequency distribution, relative frequency distribution, percent frequency distribution, and cumulative frequency distribution. Okay, here is some example which will be posted in Google Classroom. Please try to solve this problem. Okay, thank you. I think this lecture will help you to understand frequency distribution. So thank you again very much.